Our next topic is about rank of tensor. We have dealt about the tensor and how to find what is scalar vector and what is difference between tensor. So zeroth tensor. What are zeroth tensor? These are tensor without any direction. So we can say them scalars. Scalar are the tensor with zero rank. So scalar are those tensor which have 0 as their rank. So we can write 0 tensor as phi is equal to phi dash, or phi of x1, x2, x3 is equal to phi dash of x1 dash, x2 dash, x3 dash. Thus a tensor of order 0 is called a scalar invariant. We can call it scalar invariant. First order tensor. What is definition of first order tensor, and we will see what are second order tensor. An entity quantity represented by a set ai. Look at species or index. Here is single index I. So n will be equal to 1. If we write 3 raised to the power n, then here n will be equal to 1, so 3 raised to the power 1 will be equal to 3. Numbers called component relatively to a coordinate system K is called first order tensor if the component transform under changes of the coordinate system according to the law. Aj dash will be equal to Lji I. So if we write this into its components, so a1 j if j is equal to 1, if j is equal to 2, if j is equal to 3, L11, L12, L13, similarly A1, A2, A and A3, similarly A21, 2, 2, 2, 3 and 3, 1, 3, 2 and 3, 3. We can, if we write this in matrix form, then this will be equal to A1 dash, A2 dash and A3 dash, L11, L12, 1, 3 similarly is equal to A1, A2 and A3. If we write the inverse transformation of this tensor of rank 1, then simply this will be equal to first expression was aj dash is equal to lji ai. So now if we want to find inverse, so only change this expression, convert into, and here the coordinate system will be k dash. First coordinate system was k, and in inverse transformation the coordinate system will be of component, coordinate system of component will be equal to k dash, and this will be equal to ai is equal to lji a g dash. If we want to write this into the matrix form or above form which was of component form, we can write here a1, a2, a3 and this expression will be in a dash expression. So this is called our first order tensor, and this was the matrix form of first order tensor. Now our second definition is second order tensor. What is second order tensor? If index is not 1, mean we can say that the value of index is 2, then this is called the second order tensor. A quantity represented by the two suffix set a, I, j. If there are value of n is equal to 2, so 3 raised to the power n will be equal to 3 raised to the power 2 will be, which is equal to 9. So called component, there are 9 components relatively to the coordinate system K is called the second order tensor if it is if its components under change the coordinate system according to the law. This is the law we had applied in our previous section. So if we apply this law for second order tensor, then a dash mn will be equal to lmi lnj, and this will be equal to aij. So this is called second order tensor. And similarly we should learn, or we should remember the inverse transformation law for the second order tensor will be equal to aij lmi lnj and a dash mn. So this is second order tensor and first order tensor and zero order tensor. We can write in matrix form. After explaining, this will be the matrix form of the second order tensor.